As everyone knows, aircraft are a famous form of transportation worldwide. Everyone loves this transportation because it is very easy and not time-consuming. So, have you guys ever wondered what an aircraft is made out of? Did you know? Back in the days, aircraft were constructed using wood and fabrics. But nowadays, aircraft were built up from aluminium. Okay, let's dive deeper into aluminium. Aluminium is a chemical element that have atomic number 13, making it an element in period 3 and group 13 that is located at the p block in the periodic table of the elements. Its electron configuration is Ne, 3s2, 3p1, and it has 2, 8, 3 electrons per shell.
But why is aluminum chosen as the main component in an aircraft?
Firstly, aluminium's melting point. Aluminum offers excellent heat resistance. Temperature at the higher altitude of atmosphere is higher compared to at the ground level. High melting point of aluminium causes aircraft body to stay in shape even if it is hit by a high or extreme temperature caused by the weather or even heat produced by the engine. Next, the hardness of aluminium. There are multiple forces acting on the aircraft as it is traveling in amongst the clouds. Especially when it moves with high speed, the plane will encounter more air molecules and produce larger drag. Drag slows down the plane. Furthermore, like we all know, flight is mainly used as transportation where passengers must bring a lot of heavy luggage along with them. The hardness of aluminum also helps in transporting heavy loads in the aircraft. Although aluminum is lightweight, it has an excellent strength-to-weight ratio. This means that even if it has high strength, it still can stay lightweight. This makes it strong enough to withstand significant loads produced by the passengers and their stuff.
Moreover, the low density of aluminum is lightweight. Using aluminum significantly decreases the weight of an aircraft. Not only does this help the plane to stay balanced in the air, but it also makes it more fuel efficient, as the lighter the aircraft, the less fuel it consumes. In addition, at higher altitudes, air particles have higher kinetic energy and expand and occupy more space, causing the volume of air to decrease. This situation is not good for aircraft, as it requires a high volume of air to push it during its flight time. But due to its low density, this will not be a problem at all, as it is lighter and easy to push. With just a small volume of air, a flight can travel and reach its destination. This also creates high maneuverability where flight can change its path quicker. Next, aluminium has high resistance to corrosion. At higher altitude, the frequency of UV light that hits a substance is higher as there is less object to absorb and lower the frequency of the UV ray. The capability of aluminium to reflect more than 60% of the UV radiation from sunlight due to the presence of its alumina layer is beneficial for aircraft manufacturing. This is because it can result in maintaining the temperature inside an aircraft. On the other hand, the aluminium oxide layer acts as a protective barrier, preventing the underlying aluminum from directly contacting the surrounding environment. This can protect people in the aircraft from any UV radiation and inhibits the corrosion process. Hence, this produces a good weight to strength to cost ratio. This makes aluminium the best choice for aircraft making since it is lightweight and has a good strength while being relatively low in price. Thus, passenger can enjoy their flight time with less worries.
But does nowadays aluminium is still used to make an aircraft?
The answer is yes, but it is mixed few other metals, and this mixing composition is called duralumin. Duralumin is an alloy that consists of 90% of aluminium, 4% of copper, 0.51% of magnesium, and less than 1% of manganese. This is what we call an alloy, which is a metallic substance composed of two or more elements, as either a compound or a solution. This is the structure of pure metal and alloy. Pure metal layers can slide over one another, while the addition of another substance makes the sliding difficult. The presence of foreign substances causes it to be harder and stronger compared to pure aluminium.
Aircraft still can fly even during bad weather like thunderstorms, but what are the safety structures in the aircraft that make this possible? If lightning strikes an airplane, it typically travels along the exterior of the aircraft, using its conductive surfaces, like the aluminum skin, to dissipate the electric charge. The aircraft's structure is designed to handle this. providing a path for the electrical discharge without causing significant damage. This is called the lightning strike zones. Modern airplanes are equipped with lightning protection systems, including lightning conductors and bonding to ensure that the lightning energy is safely conducted away from critical components. Additionally, fuel tanks are designed to prevent ignition in the rare event of a lightning strike. While lightning strikes can be visually startling, they are a known and well-handled occurrence in aviation, and incidents of significant damage from lightning are rare due to the aircraft's design and engineering.